Hey guys, I wanted to show progress on a new auto router I've been working on for about a week now. There are currently two auto routers in TS circuit. What we're looking at here, and again, an auto router is what draws all these traces between paths, and it's super essential. So our current auto router, this is the default. It's called the intersection jumping auto router, and you can usually identify it because it has a lot of 90-degree angles, and you can see a routing between a bunch of LEDs here. So that is one type. And then if you use Auto Cloud, you use our free routing cluster in the cloud. And this one can be identified. It tends to use these sort of curves. And we know that this works pretty well up to about 200 traces. At that point, it can be a little bit flaky. So we've been working on a new auto router, and I'm going to show you some of the development work that's happened. So this is an auto routing problem. This is a very simple auto routing problem. We have this connection for these orange dots here. We have these purple dots that make up another connection. And then we have these blue dots that are a third. Okay, so in total, this is 3 traces. And then this obstacle represents a pad that these traces should avoid. So we're going to walk through each step of this auto routing problem, then look at the result. So step 1 is we create this mesh of capacities. So these are essentially nodes that each trace can travel through. And we create these nodes so that there aren't too many grid cells to pass through. So this tends to simplify the auto routing problem because you're not working with a very small grid. We then find the edges between each of these nodes. So these represent the ways you could travel between two nodes. And so every way you could travel is here. And then on the next phase, we actually solve. We run a star multi-agent A star auto router, which solves for paths. And if you hover over different cells, you can see we've used 2 out of 4 of our capacity on this cell. So each cell has a capacity, and you can't exceed the capacity of a cell. For example, this one has 0 out of 1, so it can no longer be used. So none of the other traces were allowed to use that. And so this is one part of our pathfinding for the auto router. Obviously, these traces cross over each other. They're not quite good enough yet. So we do this next phase, which is segment planning, is what we call it. But basically, during this phase, we determine where traces are going to enter or exit from the node. And it's very important because you don't want traces flipping back and forth. So this is also where we determine how busing works. So if a bunch of traces are going to travel alongside each other, it would be done at this phase. And the visualization for this isn't so great, but it does show that we know for each trace where it's going to enter and exit and minimize the number of crossings. The last phase, we compute the actual paths that the route will take. And so in this case, we can see we're using a via to go under this one, and there's a couple of those at each crossing. So this new auto routing mechanism is hopefully we're going to deploy it as an auto router soon, and hopefully we can break the 200 trace limit that we've been hitting lately.